Today's focus will be on error bounds. So step 1, we need to be able to state the upper and lower bounds. So we gotta make a decision. Step 2, we need to find the upper and lower bounds for adding and multiplying. Step 3, we need to find the upper and lower bounds for when you're subtracting and dividing. So on the bottom here, this is what it looks like. And our keywords today are bounds, accuracy, and decimals. So the first thing is, if you give an example, we need to be able to state the upper and lower bounds. So what is the upper bound for 60 to nearest 10? And what's the upper bound for 60 to nearest 1 decimal place? So for the very first one we have here, it states that if you're at to nearest 10, so you think of your spread as 10, you cut that in half or you divide by 2, you get 5 each way. So for your upper bound, it'd be 60 plus 5 to be 65. Or if you do want to find a lower bound, 60 minus 5 to get 55. Okay, so for our next one, it's what's the upper bound for 60 to 1 decimal place? So again, same deal right here. We take 60. Now the tricky part is there's no 1 decimal place here. So we gotta imagine to be 1, or in this case refer to the rule of 1. So imagine to be 0.1 decimal place. We take that divide by 2, and then we add it, or we subtract it, and we get that. So pause and try for this one and see what you get. Okay, so these are the answers right here. The way I see it is, here's my steps. The very first thing you do is find the criteria. It's either nearest 10 or 1 decimal place or whatever they ask you. You refer to 1, or my rule of 1. We take that, we divide by 2, so we get the spread of upper and lower, and we add or we subtract, depending on which one we're being asked. Again, pause to try this. I want to make sure that you understand this. Okay, here are the answers. Particularly pay attention to these guys right here, synonym figures. Okay, moving on. So step 2, we gotta find the upper and lower bounds for adding and multiplying. So let's say you give an example like here. It says the length of the side of a square, so a square, is 5.34 to 2 decimal places. So work out the upper and lower bounds for the perimeter. So again, same deal. You know 2 decimal places. So you're going to take the rule of 1, divide by 2. So you have a lower and upper. And because you're talking about multiplying, your upper bound is going to be, your lower bound is going to be this guy times by 4, get that. And your upper bound is going to be this guy times by 4 to get that. Okay, step 3, which is a little bit challenging. You got to find the upper and lower bounds for adding and dividing. Now, it's usually straightforward when you talk about perimeter and area, when you talk about adding or multiplying. You usually work with upper and upper, lower and lower, upper and upper, and lower and lower. But in this case, sometimes it's not so straightforward. Let's say you have a parallelogram of 24 centimeters squared, and its height is that. Now, the very first thing they'll ask you is, if they're nice, they say, hey, write the upper and lower bound, and then finally find the upper or lower bound for the base of the parallelogram. So, to set you up, the very first bit is here. You got the height lower bound, height upper bound, the area lower bound, and the area upper bound, which I know you could do. The second thing is when you look at the upper bound for the base of the parallelogram, a lot of people will go for this one. Or they may go for this one. I'm going to do all 4 so that you understand where is the upper bound, or in this case the greatest value, or where would the lowest value be. Okay, as you can see, a lot of people make the mistake of saying upper bound divided by upper bound, you get 3.92. But, had you done upper bound divided by lower bound, you get 3.98. So, when you're dividing, you want a mixture of the upper and lower. And let's say you want to find a lower bound, you take the lower and the upper. Comparing these two, you can see right away. So, as a summary, watch it for whole numbers to nearest 10, to nearest 100, or 1 decimal place, 2 decimal place, and significant figures. Use this model, it always works. When you're adding or multiplying, use upper with upper to define upper bounds and vice versa. And finally, when you're subtracting or dividing, use upper and lower and upper for lower bound. Here are 2 exam questions. You might want to pause to try. Okay, here's the first answer right here. And here's the answer for the second one. I hope you enjoyed this video.